Look at 121. This is how you would unpack something if you do not have access to the unpacker like UPX. You can use your debugger to unpack it. Just like I'm saying, you find the unpacking code and run it. So we're going to use PuTTY, which is just a common Windows SSH client. It's just a handy program to work with. And so when you download a file, Microsoft will mark it unrunnable, and you have to go into properties and unblock it. And then you can run this normal program called PuTTY. I've already got it here. So if you haven't used PuTTY, oops, I got to go here and here, there. So I put PuTTY in here on the desktop. So when you run PuTTY, PuTTY just pops up this window so you can connect to something. So if you connect to a server that is an SSH server, like I'll use one of mine. Got to spell my name right though. All right, you can connect to this thing and open, it connects. And now you can say yes, that it's okay to trust this host. And now it asks me to log in as. And if you know the right username and password, you can now open a session. And that's all PuTTY does. So what we're going to do is compress it with UPX. So let's see if I don't have a command prompt open. I'll open another one. All right, go to desktop. And dir should show PuTTY. And it does. Okay, now I can run UPX and compress it. I'm just going to check my instructions to get the command right. UPX -o PuTTY. Okay, good. So UPXO. Come on, come on. Okay, there. That will compress it. So it goes from 531K down to 267K, and should be on the desktop. There it is. Now, this is the part that at first seems pretty mysterious. This will run just like before. If you run it, here it is. It works just the same because it's only compressed the file on the disk and then added a custom loader that will unzip it and put it in memory. So the memory image will be the same as this one, but the disk file will be smaller. That's all it does. All right.
It just makes the smaller file size, right?
Yes, and therefore it obscures the strings. So and if you use a custom compressor, it's not easy to decompress, so the analyst can't find the strings or anything to analyze. So it's an anti-analysis technique, in addition to saving space. All right. So you can use pestudio to get information about it, and let's try that. pestudio is a very handy sort of suite kind of tool that will give you a whole lot of information. pestudio. All right, let's run that. All right. And I'll put in normal PuTTY. All right, there it is. Now it sends it to virus total automatically, and it does analysis for suspicious things, which can take some time. So part of these are still running, but here you see the MD5 and the SHA. The indicators are what's still running, looking for suspicious things. Okay, it found 56 suspicious things in PuTTY, and here they are. It references strings. It references an API type that might be used for obfuscation. It references a string with a suspicious size, 1,316 bytes. By the way, this is a harmless, good program. It's not bad at all, but this program regards 56 activities it did as suspicious. Virus total flags it. Apex marks it as malicious. This must be, I've never heard of them. I guess for a good reason. They appear to be idiots. You know, they're counting PuTTY as malicious when it totally isn't. So this is usually the case. Even a clean file, some malware engine somewhere will misunderstand it and mark it as malicious. The rest all find it clean, of course, because it's just a normal program. Here's the DOS header. Gives you the entropy of the file, which is a measure of whether it's packed or not. When something is packed, its entropy is nearly 8. When it's not packed, it has a lower entropy, and this is 4.5. All right, and here's the sections. You've got text, RData, data, and resource. And you see it gives you the entropy for each section. So the text section, which is assembly code, has a high entropy of 6.7. It's almost random. As assembly code is, it's these unpredictable instructions. Totally random would be 8. The R data is also similar. The data is low entropy. This is probably strings. which are low entropy. And here's the resource value, which is also low entropy, and it tells you something about it. You've got entry points here. This is where the code enters. All right, that's normal PuTTY. I think that's all we need to do there, but let me get back to here and see if there's anything else I wanted to point out. Okay, sections. Oh yeah, the raw size and virtual size is the same for each one. I'll bring up my live there. Raw size is here, and virtual size is here. And you see if it's 51C, this is 401,000, this is 1E, and I don't know, the raw size and virtual size are not very close in that case.
No,
For the
what is
art.
the address? What is the size?
Oh, the address, up here, size and size. Where's the, oh, down to, good, thank you. 5C, 5B, there we go. 1E, 1D, 2000. So this is what I'm saying, on disk, it might not fill it up, but it expands in sort of even number in memory, like 2000 in hex. So they're similar, because the file on disk is very much, almost exactly the same as the file in memory. Each section is just copied into memory, and then there are some gaps, because it rounds off the memory sections to start on even thousands.
And it's always been doing that since,
Yeah, that's the way every program works. That's the standard way they work.
okay.
So they're almost a exact one-to-one match. All right, now I think that's all what I'm going to mention. Let's see, anything else? Oh yeah, permissions. The text section is executable and the data section is writable. That's useful to see. Here's the text section, and permissions are, where are they?
Right there.
Executable. Okay, there's executable is here, and writable is here. So this is executable, that's the code. This is writable, that's where the stack is going to go in data. And the two, you never have writable and executable in the same section. That is the standard security policy of Windows and most modern operating systems, the only exception being an older version of the Raspberry Pi. You don't let a section be writable and executable at the same time, because that would imply code injection. Such a big difference for our data, I don't think there is. It's 1E versus 1D. Yeah, that's because I was looking at the wrong lines, which I think we figured out. All right, so let me get back to here. There's the entry point. All right, we talked about the entropy and the entry point. So now if you look at PuTTY compressed, I think we'll just look here, then you'll see, well, here's PuTTY compressed. You have UPX 0 and 1. This one has a raw size of 0. It's just an empty container on the disk. There's nothing there. Everything is in UPX1, and that's high entropy, 7.9. So what's going on, of course, is this is the packed whole program, zipped into one little section, and the unpacker will unpack it and load it into memory as the sections. So you can't even see them. And by the way, this is a mistake in the designer of UPX. He wanted to compress all the sections, and he misspelled resource. So the resource sections goes through uncompressed. That's a bug in UPX, but he intended everything to just be compressed in here and hidden. Anyway, that's what compressed things look like. If you look at the imports, you can see the functions it uses. And in PuTTY compressed, it's a much shorter list of functions because they're just seeing the unpacker.
Is UPX automatically runs?
Does automatic? Well, yeah, the compressed file includes its decompressor. So when you run it, it automatically decompresses. Is that what you mean? Yeah. Just like a self-extracting zip file.
Oh, the compressed file automatically call up the UPX.
Yeah, the compressed file automatically decompresses when you run it. But it only into RAM. It does not create a decompressed version on the disk, and that's to hide from antivirus.
Is that only for UPX?
No, they all work that way.
They all work that way?
Yeah, that's the idea, because you're making an executable that you can deliver like a virus, and it will expand into memory, but the disk file will not include any of the strings that would trigger your antivirus or help the analyst. That's the idea. So there's some things to find here practicing these, and now we're going to manually unpack it with OllyDbg. So we're going to manually unpack this compressed PuTTY, and so here we go. We're going to open PuTTY in OllyDbg. We're going to have 2 copies of OllyDbg running both of them. That's the thing to do. So let me get rid of PE Studio and run Olly. All right, there's Olly. And I'm just going to open the normal PuTTY. There it is. Okay. Okay. And a little small, but I think I'm going to try and make the font bigger. Just a minute. This might take a minute. Options, appearance. Ooh, this might be easier than I thought. Fonts. There we go. Change. All right. To something bigger. Let's see how that looks. There we go. Good. It got bigger. Okay. All right. So here, this is OllyDbg. It starts with 6A 6068. That's the unaltered PuTTY. Now we're going to make another instance of Olly and open the compressed file. Now it's going to warn me something looks wrong about this program. Its code section is compressed or encrypted or contains a large amount of data. So that's weird. Do you want to continue? I'll just say continue. Okay. Now I'm going to change the appearance the same way I did before because it didn't remember it, which is a drag, but you can't have everything. All right. There we go. All right. And so now this is 60 is followed by BE0090. As you might have expected, these are different. This is the compressed file. So this is the real PuTTY. This is the decompressor. So you can see what's going on here. It's actually very easy to do, even without looking at the details of the code. If you just scroll down, I'm just trying to make the part on the screen. There, now you see all the usual stuff like registers. Here it is starting to work. Now if I just scroll down a bit, I don't have to go down very far before I hit the end of this code. There. Nope, not yet. There we are. It's all just zeros from here on. That is the the unpacker. That's it. Just that, maybe 40 or 80 lines of code. So it's going to unpack everything, and then it's going to jump into a location which is going to run PuTTY. So if you want to unpack it manually, you just put a breakpoint there, which you can do. There's a way to do it up here. F2 is the key that works. That's how I'm going to do it. I can't remember how to do it from the menu. So F2 puts a breakpoint there. Now, if I view the memory, right now, I've got PuTTY comp here, and the only sections are UPX0, UPX1, and resource. And if I look at UPX0, it's here, 401 to 488,000, and if I view that, I can dump, and you see it's all just full of zeros right now. That's a memory, it's reserved memory, reserved space to put stuff, but there's nothing in there right now. Now, if I go back to the main thread and run this code, I put a breakpoint there, so I can just run it. It'll run and stop there. And now, if I go back to the memory, this is all full of code now. It unzipped code into that section. And now, if I let it jump to go where it's going to go, which is here in the CPU, now I want to take one more step. So that is F7, single step. It's also one of these buttons, but I forget which one. I'm going to use F7 to do it. I want to take one step to jump in there. And now, didn't seem to work. Function F7. Nope, that did something weird. All right, I'll have to try and use the up here, debug, step into. Well, I don't know what's going wrong here. It should be going to 486.283, and I don't think it did it. Oh, it did. It went down here. Okay. Anyway, what I was hoping to find, and somehow I failed. Oh, I have a breakpoint. Seems to be my break. Yeah, I did. So I put breakpoint in the wrong spot. I want to go here. Let's just keep doing debug. Step into. Okay. Somehow I stopped. So I stopped at the wrong point. Okay. I somehow stopped a little early.
We jumped to that point. 486.283.
But I want to go here, 4550F0. That's where I want to go. So somehow I'm stopped at the wrong point. You people that step into. Am I getting anywhere? Does F7 work? Maybe F7 works. Jump,
Just
jump.
go
Oh, I'm going through a loop or something. Okay, right, I got it. Okay, I put my breakpoint at the wrong point somehow. I see. That's my fundamental problem. I need to get rid of this breakpoint and put a breakpoint here. Okay, I put a breakpoint in the wrong place. So I did not finish unpacking. There, now I can run. There we are. Now I'm at the right place where it's done unpacking. And now I do one step with F7. And now I end up here. And the point I wanted to show you is this is the original putty, 6A, 60, 68. That'll match the other Ollie, 6A, 60, 68. It unpacked, and now it's going to run the original putty. So that, you can see how the unpacker works, and that's what, so that's the essence of how you unpack unknown packers. You run the unpacker that came with it and stop, and then you've got the code in memory. And so you can just dump it from there. You can view the strings in memory and such. You can dump the sections, and you can also even use a putty OllyDbg, this extension that will actually dump it back into an executable on the disk. And so that's Polygon's OllyDbg dump debugged process. And the only trick is you have to make sure that these two numbers add up to the real address. So in this case, it'll be easy. And then I found when I dump it that the dumped file is often not accurate enough to actually execute, but all the strings and functions and everything are intact, so you can analyze it with pestudio and so on. So that's what I wanted to show you. And there's a few challenges here where you have to unpack some things that are packed with other packers and stuff. So you can manually unpack things, and this general procedure works for all kinds of malware. You find the code that does something like decrypt it or unpack it, and you just isolate that code, and you can let their code do the work. You don't really have to understand every detail of it. So that's what I wanted to show you. And I think that's it for the demo.